Hey guys, myself Gaurabh. I'm currently leading the whole QA here at GeekYants India Private Limited. And so before I actually want to jump into the topic, which is mobile app instrumentation, I'm wanted to share a couple of facts with you guys. Very interesting facts. You can, I mean, I'm sure that almost all of us nowadays are using smartphones, smart devices, and most of us have noticed that if at all your application doesn't respond properly, or if it is little jittery or laggy, we tend to uninstall the app. And then there is a research in which we have seen that out of 10 people, 9 people would do that. There's so much of hard work that you guys put in to build an app, put it to Play Store, and then why would people actually make use of it if they don't, if the experience itself is not good? So I hope you're getting the point, right? To make an app just look beautiful and doesn't give the user experience, that's something nobody would want. And there are other couple of numbers which are mentioned on the screen. Pretty interesting these are. If you quickly have a look into those, maybe I'll just read it through. With almost 3.5 million smartphone users, it's no surprise that the mobile application industry is flying high. Over 60% of business across the globe have an app or are in the process of developing an app. And also studies have shown that millennials have around 30 to 40 apps on their phones, out of which they spend individual apps, they would spend time on approximately 18 of them. So these numbers are promising, isn't it? But then what is app profiling? I'm sure that you guys would be thinking about it. What is NFR? What is non-functional testing? So apart from the usual testing that we do, let's say the functionality, UI, UX, NFR would be non-functional part of it, wherein we check for profiling part, the hardware resources that it is consuming, or let's say your application is showing some sort of again a delay, app launch is slow, some activity or screen is taking a lot of time to respond. So these things has to be dealt, which we tend to forget. But once the application is there on the App Store or Play Store, that's where we face issues. We see people complaining about it, and how to look into those issues. How should we be going ahead and fixing those? This is what we're going to be discussing about today. So let's jump into it. So we all know that our application pretty much depends upon these three things, which is first backend, the network, and definitely the app itself. By backend, I would say there is, and it could be as simple as just the cloud functions and APIs. The network would definitely be your network carrier or Wi-Fi, whatever you're using, and the code, how you're coding. So these three are the major factors behind your app's performance. But it's just not these three things itself. There are a lot of things which are involved in it. Right. So I'll start with the CPU part. As we all know, the functionality of CPU. CPU is not the cabinet which we used to think it is in our, I'm sure in our school days or in our college days. CPU is that small chip that is there inside your mobile devices. Not sure if you guys have seen how it looks like inside your mobile device, the CPU part. Laptop you might have, desktop you might have, but see, in mobile it's even more compressed. And if you have heard of Apple, if you are a fan of Apple, as I am, you would have heard about the M1 silicon chip, now M2 silicon chip as well. So CPU plays the major role, right? It executes the process, it runs your whole code or program or software application, whatever it is. That's the job for the CPU to do it. So if the CPU itself is consuming a lot of bandwidth, eventually what's going to happen, your app's performance, or let's say because of your app, the other app's performance will be hampered. So we can actually do a profiling of this part using multiple tools, one of which, if you can see the screen, it's the Android Studio which is being used. So there is a concept which is related to humans vision. What happens usually, and a person can see a smooth animation or a smooth video when it's 60 frames per second, or it's also the same thing can be also said as 16 milliseconds rendering time should be taken for every individual frame. To understand it in a better way, I would say you would have taken photos. If you take multiple photos and one by one, if you just see them, it'll become like a video, right? That's what actually happens in a video as well. There are multiple photos which are stitched together and you see that over a period of time. So that's what FPS, frames per second, would mean. And if your application is not rendering within 60 seconds or 60 FPS or 16 milliseconds, there's going to be jitteriness, janky frames, which is definitely not a good user experience. And apart from that, definitely the app startup time is one of the very important thing. If your app is consuming a lot of time just to open up, you might lose a lot of your customers. Again, that can be traced down using Android Studio itself, particularly if you're talking about Android. If it's iOS, we have again Xcode instruments, or let's say if it's React Native or React based, we have multiple different tools for that as well. My favorite would be Flipper. So let's talk about the app startup time itself. There is something called as latency. So what is the latency? Latency is nothing but, let's say your application is waiting for something to happen so that it can start executing. Let's say there are times when we have used some sort of an API which is calling some XYZ data, and that API is not working. And since the other things are dependent on that API, the application is not turning on itself, or it's taking a lot of time. So how do we look into those things? We should be jumping ahead and looking into all the network calls. Either we can use proxy tools, we can use Android Studio itself. Again, if it's iOS specific, we can use Xcode instruments. Xcode also we can use. We can look into the different network profilers, proxy tools to get details on all that. Second pointer, if you see these, this is GC is not Gaurabh Chakraborty, which is my name, by the way. GC is garbage collection. So if the coding practices are not being done in a proper way, what happens? There is no proper garbage collection, which means the utilization of memory when the process is being executed. There are times when there are things which are not needed. Let's say you would have declared some object somewhere, some function, some method, and then at that point of time that is important, but as you go on, that is not important, and that has to be cleaned. That's so that's that memory cleaning part is right. So as I was talking about GC, there are different types of GCs as well. There is MLOC, CLOC, ReLOC. We need to be very cautious about GC because GC is again very heavy on our resources consumption as well. So after Android 4.4, which came into picture, before to that it was little difficult. We would have seen a lot of out of memory crashes because at that point of time Dalvik was used, and now it's ART, Android runtime, which is being used. So I'm just discussing specifically to Android, nothing to do with iOS, because you mostly will not be seeing such issues over there. Apart from that, there are three more things which are mentioned there, which is slow cold start, warm start, hot start, and also the numbers are mentioned, like the cold start should not take more than 5 seconds, hot start should not take more than 1.5 seconds, warm start should not take more than 2 seconds. Cold start is where you're running the application from the scratch. There is no process ID which is there, nothing is running in the background. You are starting the application after killing it. Warm start would be, a hot start would be, let's say you have the application, you just press background, and then again you came into the foreground part. So that's the hot start. And the third thing, warm start, which comes in between the both. Warm start would be, let's say you are using an application, you put it in the background, and you're using other applications, and then at some point of time you realize you come back to your application. That's warm start. Yep, GPU profiling. GPU, again, it's another very much resource consuming part or hardware component, which is definitely used for graphics processing, right? So how does that come into picture? First of all, definitely you have multiple images, videos, which are supposed to be displayed on your mobile screen. So that's where GPU comes into picture. But then how can you actually take care of GPU part, or how can you understand what is causing the problem? Or if, let's say, as the name suggests, GPU profiling, how it's done. Your mobile application, your Android device itself has developer options which you can make use of. You can get inside that and go to a section which says GPU overdraw. Turn it on. You will see such sort of colors: blue, green, pink, and dark red. So the darker it gets, the more number of times that particular element is being rendered. Our goal should always be to minimize that, to reduce that. The tree structure that is being created, the DOM structure, so the number of subtrees should be minimized so that the GPU's involvement is less. Most of the times we don't look into this part, but as I said, it's very much resource consuming, and because of this your battery drains out very fast. Network profiling, I have already discussed about it. As I said, we can use multiple tools to look into the network part, like proxy tools and the Android Studio itself or Xcode Instruments itself, and try to understand if any API is taking a lot of time to respond, or there is something unnecessary data being fetched, or multiple calls are being done. So those things should be removed, should be taken care of, provided you have authority to the backend. If you don't have the authority to a backend, you can't do much, right? But yeah, at least you can tell them that this is the thing which is happening. Multiple calls are being made for the exact same thing, which should not be done. Maybe in detail we'll discuss about all this sometime later. I'll just push to the next, which is battery profiling. So there's a concept with the name of wake lock. Wake lock is nothing but this is something which is going to keep your device keep awake and lock it. So wake locks are of different types. There is CPU wake lock, there is screen display wake lock, there's Wi-Fi wake lock. What does that do? As I said, it's going to be keeping your XYZ application or hardware component awake. For an example, you can consider YouTube itself. If you use YouTube, you watch with YouTube, you just keep your phone and it's not going to turn off by itself. It's going to continue showing you the video unless you manually turn off your display. So that's where it's making use of wake locks. It is important definitely at some point of time, and sometimes we tend to forget that we would have called wake locks for some reason and we have forgotten to stop it. So we can use again battery profilers. We can use Android Studio to look into and understand where is the wake, if at all there are wake locks, are they being used deliberately or not. If not, we should be getting rid of those. Yep, that's pretty much, I guess. We have already covered about what NFR testing is on the surface level. What are the key matrices? How should we be looking into those? How are they individually impact our application, and how to address them? I guess I have pretty much covered all this. By the way, if you guys have any questions, please feel free to mail me. That's my mail address, and that's my time. Thank you so much, guys. Have a nice day.